PYQs of DBMS. So can you see the session? Okay. So you can see the question, everyone. The question is, so this question is particularly asked in UGC NET December 2023. Right, everyone? So let's see. Consider the following relation X, and here S, Si, C is there, and Y, S, P, D is there. Number of tuples obtained by applying Cartesian product over X and Y are. So what is the answer? So first you all try for 1 to 2 minutes, and after that I will help you understand how to solve such questions. So once you have done this question, please be interactive. Like let's write the whatever the answer you have got, write in the comment box. Okay, I'll check whoever is giving the correct answer for this question. So this class will be of 30 to 38 minutes. Okay, so let's practice more and more questions on DBMS. So in the last class, I have also taken the practice class of AI. I have also taken the practice class of OS. And this time I'm going to take the practice class of purely DBMS. And all the questions we are going to discuss. So Kriti is saying option is 16. Very good, Kriti. Your answer is correct. Let's see the solution on this, everyone. So all this is given. So what is, if you are doing the Cartesian product, so what we have to match every row, and for every column we have to match. So here you can see that how many rows are there? 1, 2, 3, 4. 4 rows are there. And how many rows this Y has? 1, 2, 3, 4. 4 rows of Y. Cartesian product means this particular J will be mapped with all the values of Y. And how we are going to get the attributes? S, Si, C, P, D, like this. All you agree? And this particular J will be mapped with everyone. Similarly, B, R, T will map. So X has 4 rows and Y also has 4 rows. So total 16 are there. That is why here A is the correct answer. Okay, everyone? A is the correct answer. So let's see now the next question, everyone. So I'm bringing a next question. Let's solve that. Yeah, this is our next question. So what do you think is the correct answer for this? Which of the following database object does not physically exist? Answer, everyone. Answer this all. So which of the following database object does not physically exist? Base table, index, view, table, none of the above. So let's answer this. So the concept should be very well clear. What is a view? Okay, a view is a result set of stored query on the data in which the database users can query just as they would in the database collection. So that is why here, which of the following database object does not physically exist? So it is a view, right? Because in SQL, a view is a virtual table based on the result set of an SQL statement. And a view contains rows and columns, just like a real table. And in fields, views are like one or more real table in the database. Alright everyone. And if we talk about index, so index is a data structure that you can use to improve the performance of database activity. And if you talk about system-based tables or a base table, so it is a table in which database where we are positioned and working at a certain time. For example, we can say that retrieving or modifying its data. Right everyone? So that is why we can say that view is the correct answer. So all you agree? Okay, so let's take the next question on this. So next question is on 2PL protocol. So if you know this topic, you can easily solve the question based on this. So this is our next question. I will increase the font so that you can see this properly. So the question is 2PL guarantees serializability, but it does not prevent deadlocks. 2PL has two phases, growing and shrinking. So this is all basically the definition of 2PL. Which of the following rules are used to govern the 2PL protocol? First is two transactions cannot have conflicting locks. B is no unlock operation can precede a lock operation in the same direction. C is no data are affected until all locks are obtained. That is until the transaction is in its lock point. So what do you think are the correct answers for this? So those who know about 2PL, they can only solve this question. So can you confirm in the chat box? And those who want to understand certain topic in any subject of UGC NET, they can comment it below. So I'll make a video on that particular thing. Okay, I'll teach the particular topic if you want me to teach. So there are various tough topics in OS, COA, right, DBMS. So read the question properly and answer. I will wait for 1 to 2 minutes and after that I will explain the question. So we have to know that to analyze the rules of governing 2PL protocol, we have to see for two conditions. Two characteristics of 2PL we have to see. First is two transactions cannot have conflicting lock. So this is correct because this rule ensures that if one transaction holds a lock on a resource, another transaction cannot obtain a conflicting lock into it. For example, if we take two transactions are there, cannot hold lock for writing on the same resource simultaneously. So that is why this statement A is absolutely correct. If we talk about second one, which is B, no unlock operation can precede a lock operation in the same direction. So this is also correct. Why? Because in 2PL protocol, once a transaction starts unlocking, which is a shrinking phase we say, it cannot obtain any more locks. So it helps in maintaining two phases, which is growing phase where the locks are acquired and the shrinking phase where the locks are released. right everyone? And the C is no data are affected until all logs are obtained, that is until the transaction is in logged point. So what this means, this is also correct, because this rule implies that a transaction will not affect the data until it has secured all the necessary logs and ensuring data integrity through the transaction. So are you all getting my point? Please write yes or no. Okay, so according to this, we can say that all are correct. Option 4th, A, B, C, all are correct into this. Now let's see the next question. Yeah, let's see this question. So read the question properly. Arrange the following phases of database design in correct order. A is physical design, B is conceptual design, C is logical design, D is requirement analysis. So what do you all think is the answer for this question? So can you all solve this question and answer? So we have to arrange this in the correct order. So which will be the correct order? Is it option 1, option 2, option 3 or option 4? So first, we always want a requirement analysis. Why? This is the initial phase where the requirements of the database are gathered. What is the requirement, right? It involves understanding what data needs to be stored, how it will be accessed, and what constraints and rules must be applied. So this all comes in requirement analysis. So this is the very first step. I will say that this is the initial step. So D is fixed. Now when D is fixed, so A is automatically will get cancelled, C will automatically will get cancelled, 4 will automatically will get cancelled, 3 is the option. But now we are not in exam, so we have to analyze all the other options as well. After that, the second will come is B, which is the so B will come conceptual design. So this is, in this phase, a high level data model is created, often using ER diagrams. What is ER diagram? Entity relationship diagram. This model represents the main data entities and the relationship between them. Let's say if I take the example of student. So this is a teacher teaches student. So these are two entities, teacher and student. Relationship between them is teaches. Or if this is student and this is teacher, so it learns. So this is the work of conceptual design. Alright everyone. Now which is the next one? Next one is C, logical design. So the conceptual design model is then translated into logical model. And what this involves? This involves the tables, column, data type and relationship in a way that can be implemented in a database management system, which is DBMS. So logical design is important. And after that, everything is over. A is there, which is physical design. So the final phase involves creating the actual database scheme. This includes defining the storage structures, indexing strategies, and other performance optimizations for the specific DBMS being used. Okay everyone, so that is why 3 is the correct answer here. Any doubt in this question? So let's take another question. This is the next question. Such questions are also very, very important, whatever we are taking. Very good, Tiwari. Are you answering for this particular question? Second. So answer everyone. Fifth normal form is concerned with what? So whole table we have for this one. Joint dependency, where it comes, domain key, where it comes, after that multi-valued dependency, functional dependency, everything. So what do you think is the correct answer? Write in the chat box. I want everyone to answer this. So if you will solve all the bunch of PYQs right for UGC NET, you are really going to get a great help from this. So answer this. So all that end is, please answer this question and write in the chat box what do you feel is the correct answer. So if we talk about joint dependency, so what is joint dependency? Can anyone answer in the chat box? A relation in 5NF if it is in 4NF and all the joint dependencies in the relation are implied by candidate keys. And what this means? That a relation can be decomposed into smaller relation and those relation can be joined to recreate the original relation without any loss of information. And then the relation is in 5NF. So you all know that what is decomposition. So this is a relation A, B, C, D given. We can decompose this into several relation, right? And once we will join this, still it should give us the original table, right? And who will give this? Joint dependency. So that is why fifth normal form is concerned with joint dependency. So what is domain key then? So domain key refers to constraint based on domains and keys. Okay, it based on domains and key, but it is not specifically related to fifth NF. So that is why this is not the correct answer. If we talk about multi-valued dependency, so multi-valued dependency is concerned with 4NF. It has nothing to do with 5NF. And a relation is in 4NF if it has no trivial, non-trivial multi-valued dependency. So those who don't know, please make a note of this. If a relation is in 4NF, it has no non-trivial multi-valued dependency. And if we talk about functional dependency, so it is related to first NF, second NF and third NF. But it does not directly address the concerns of fifth NF. That is why here joint dependency is our answer. Any doubt in this question? Should we take next question now? Very good. So please solve the next question everyone. So those who are answering in the live chat, I can see their answers. Solve this question everyone. This is a very nice question asked. Read the question everyone. Which of the following relation cannot be decomposed into BCNF with a lossless join and dependency preserving decomposition? These all are the relation given to you. Which is the correct one? So should we start to discuss if you are not getting this question? So let's see. They are asking for which of the following relation cannot be decomposed into BCNF with a lossless join and dependency preserving decomposition. Okay, now if you see all the options, so if you try to see this, if you try to see option 3, so which is VW is deriving X. Okay, so we cannot have this V and W and X together in any of the BCNF relation, right? Because why? If you write VW X, so X is not a super key. Okay, X is not a super key, and if you will see this X is deriving Vy, this exists and it is violating the condition because X cannot be the super key in this, and here in this it is completely violating the condition, and that is why we cannot preserve VW is deriving X in any of the decomposition of VWXY. Alright everyone, so that is why third is the answer. Now if you try to see this, so VW is deriving X, it is fine. Vx is deriving V, this is also fine, but particularly we cannot do this. Okay, because if you will try, so how to find out like BCNF decomposition, if it is in, we always require CK. If you try to take out the CK for this particular value, so you can see that VWXY is there. So how to find out CK? VW is deriving X, X is deriving Vy. So if you check in at the right hand side which of the attribute is not present, so that will be definitely in our CK. So V is there, W is not there, W will definitely be there, X is there, okay, Y is there, but can W itself derive all the attributes? No. So we have to now consider the pair. Let's say VW. After that we will consider Vx and we will consider Vy, and we will check that whether they can derive or not. So VW, if you try to take the closure, so it will be VW. VW is deriving X and X is deriving Y. So VW is definitely the key. And if you try to see Vx, this one, so Vx and X single can derive just Y, and Y cannot derive anything, so that is why Vx is definitely not candidate key. And Vy, if you see, so V and Y is not deriving anything, so Vy is also not the candidate key. So here the candidate key is just one, which is VW. VW is a candidate key here in this. So this is a candidate key and this is not a candidate key, so definitely this cannot be decomposed, okay, into BCNF. So they are asking which of the following cannot be decomposed. So this cannot be decomposed, this functional dependencies. Alright everyone, because see, VW is a key, it can, WX it can, after that Vx it can, W itself can, and Y. So if you will check the options, so you will get whatever I am saying in this, right? So that is why 3 is the correct answer here in this case. So everyone understood? So first, whenever BCNF or any kind of decomposition you will see, first try to get the CK. And as you can see that VWX, if you will try to see this, if you will try to check, and X Vy. So X Vy, as you can see that here V is already there, so here V cannot be there. Here V cannot be there, here just XY will be there. And through XY, here X is deriving Y. But what about XV? This is not preserved. But when we say that BCNF, it is lossless and dependency preserving. So that is why 3 is the correct answer. If you will check for others, so similarly for the option first also you have to first find the CK. After that you have to check that whether all they are CKs or not, whether they are in BCNF or not, right? And after that you have to see the lossless join and the decomposing preserving. Dependency preserving, you have to check for this. Alright everyone, so these are the several steps which you have to perform. So similarly you can see for VW is deriving W and XY. So this easily we can decompose. Why? Because XY you will keep and VW you will keep. So everything is preserving here, and they are like lossless join also. Now how to check for the lossless join? I will show you. See, let's say here we did VW and XY is decomposed. And for the lossless, this is a trick which you can make. VWXY. And the decompose relation, this is R1, this is R2. Okay, these are some columns. So R1 if you will keep, so alpha, alpha, like this you have to keep. Second is X and Y you have to keep like this. And after that what you have to do, you have to check. So VW and W. So VW is deriving W itself. So like this you have to check. Alright everyone. From this, and if any of the row will match, so that will be basically our answer. And if you will try like this, so if you are keeping V also, VXW, so like this, okay, or you can keep here X also, so VWX also you can keep. So VWX if you will keep in this, so it will be like this, and easily from X to X you can derive this Y, and from this you can say that, so if at least any of the row is feeling this way, you can say that this is a lossless decomposition. So you can make this. So but third option is not the proper one. If you have any doubt in this question, you can ask me now. So 3 is the correct answer in this case. Let's take now the next question. Solve this question. So this is a conceptual question, not a theoretical one. So it's a theoretical one, not a conceptual question. So solve this everyone. So every time we just focus on theory, okay, but we lack in solving sometimes the theoretical questions as well. So you have to be good in both, solving theoretical questions as well as conceptual questions. So the question is, fifth generation language are the assembly languages, machine languages, constraint based languages, higher level languages, none of the above. So what do you think is the correct answer for this one? And this is a very short session, but we are going to do a nice practice on this. So please be attentive everyone. Okay, so let's discuss this. See, programming languages are classified in variety of ways, and generation is one of them, right? Because generations are further classified as first generation, second generation, third generation, fourth generation, and fifth generation. And fifth generation languages apply to logic and constraint based languages like Prolog. Okay, and if you see assembly language, so I will write assembly language comes in second generation. Second generation. And machine languages comes in first generation. And constraint based languages, I have already told, high level languages comes in third generation. And constraint based languages comes in fifth generation. Fifth generation. And how the generations are classified? On the programming languages. Okay, and fifth language is constraint based. And what is the example for this? So the example for this is Prolog. So that is why third is the correct answer here in this case. Let's see now the next question. So this is a very good question. Try to solve this, everyone. Yeah, solve this question, everyone. Find minimum number of tables required for converting the following entity relation diagram in relational database. So this is the easy one. You all can answer. So I will correct also if someone is giving wrong answer. And well, I'll appreciate if someone is giving the correct answer. So find the minimum number of tables required for converting the following entity relationship diagram into relational database. This is entity R1 and this is given. The relation is one to many. All you all know the constraints of one to many. So in one to many, how many tables are there? So rules for finding minimum number of tables required for ER diagram. First is a strong entity with single or composite attributes requires one table. So a strong is there. Strong entities is there. There is no weak entity. Second is strong entity with multi-valued attributes require two table. You can see here multi-valued is required there. So it will require two tables. In case of many relation between two entities, three tables are required. But here many to many relationship is not there. So that is why three tables are not required. Now if you see for this particular question, so there is one to many relationship between R1 and R2. So two tables are required for two entities. So first table is required for R1, second is required for R2. But the entity R1 contains multi-valued attribute B. So due to that we need one more table which is of B and this will have the key. So it will be merged with the key of R1 and B. Okay. So how many total tables we will have? R1 table we will have, and this this R1 has no attributes, but if this has, so it will get merged with the R2 many side. You all know that when one to many is there, so the relationship attributes merge with the many side. So that is why it will be having R12 will merge with the R2. Okay, R1 will be there and B will be there. Okay, so it is a multi-valued. So total how many tables are required? Total 3 tables are required. Okay everyone, so that is why here the correct answer is 3. So some can directly say that, some can directly classify that, okay, it is one to many, so directly 2 is the answer. And that is how they get things wrong. You also have to see multi-valued attribute. It will definitely require a table. And why multi-valued requires a table? Let's say here A is there, it has 2 phone numbers. B is there, it has 2 phone numbers. It is taking a space. And this A is, let's say this is a key. So what we can do, this multi-valued attribute, we will take it into another table where we will have S, okay, A, one column, A, another column, and this 2 particular column, let's say this, will be the key. Okay, and here also if you will try to expand this like this, so S will not remain a key. So we also have to follow that constraint too, that S should be the key. So that is why for the multi-value attribute we always take a separate table. And for this particular question, as we have taken a separate table, so that is why 3 is the answer. And if B is not a multi-valued, it is a simple attribute, then your answer will be first, which is 2. When no multi-valued attributes are there and the simple relationship in the entity is one to many, so the answer is always 2. But here multi-valued attribute is there, so answer is 3. So very good, 3 is the correct answer. And yes, now X is also multi-valued attribute. 2 multi-valued attributes are there. Can you all answer now? I have just modified it, because the options are also provided. Can you all answer? So the modification is done like this. B is also there and X is also there. Can you all answer now how many tables are required for this question? So those who have understood this question, they can only answer the correct answer, okay? So this is the last question of the class. Please solve this correctly. Think about it. What can be the answer? And those who want me to solve the PYQs of the next subject, they can just comment it below. I will bring some sessions on those subject PYQ, and we will have a nice set of practice. So if you come to the question, so you can see that here again R will have a table, R2 will have a table. So R2 table will be merged with R1 R2 relation. B will require a table and X will also require a table this time. So if you modify this question, so this time 1, 2, 3, 4, 4 tables will be required, because every time multi-valued attribute will have a separate table. Got it, everyone? Any doubt in this question? And if you say that, let's say X is also C is also multi-valued, so 2 tables are required for one to many. After that 1, 2, 3. So plus 3 for multi-valued. So 5 tables are required. Everyone. So that is how some modifications can be done in the next year paper. Okay, everyone. So if you really like this session, please like and comment whatever you want